standard 10, we will be taking up the second chapter in physics, again related to light, and we have already seen two different phenomena that occur whenever the ray of light touches a different surface. We have seen reflection, which is a simple bounce back of light, and we have seen diffraction, when a light travels from one optical medium into the other. It changes direction and we call it refraction. In this particular chapter, we will be learning now about three more phenomena of light, namely dispersion, absorption, and scattering of light. It is a very common experience that in the night, if we are traveling in a train, if it is raining outside, our glass pan windows will be closed. What we will see is the inside of the compartment, the color of the glass pane, and the lights passing outside. Now, because we can see the inside of the compartment, we can easily infer that a part of light is getting reflected back. The outside light traveling from one optical medium to another and therefore bends, and we also see refraction. But the color of glass that we see here is absorption of light. Now, what do we understand by absorption, and why do we see different colors of light? Let us take a solid glass slab which will have two rectangular surfaces. And two triangular surfaces and three rectangular surfaces. Such a solid piece of glass is called a prism. Now, what is the importance of a prism? Whenever we perform any experiment with a prism, what we do is that we keep the triangular side of the prism on our drawing paper. There are many different types of prisms, but in the current chapter we will be restricting ourselves to equilateral or equiangular prism. That will mean all these three angles are 60 degrees. Suppose we have a white light made incident upon the prism. The light would travel inside the prism and get split into 7 different colors. And we can capture all the 7 different colors on the screen. However, for a very good eye, it is difficult to see more than 4 colors because they mingle with each other very beautifully. For a normal eye, we can only see 3 colors. However, the white light is made up of violet to red, 7 colors. We have vitriol, like indigo, blue, green, yellow, orange, and red. Always remember that though we call it vitriol, red color will always be on the top and violet color will always be at the bottom. This phenomenon of splitting of white light into a spectrum of 7 colors of which it is made up of is called dispersion. of light. Like I said, in any ray, even in a rainbow, all this spectrum, for a normal eye, it is difficult to detect more than 3 colors. But theoretically, the white light will be made up of violet, indigo, blue, green, yellow, orange, and red, 7 colors. If instead of a screen, we put another prism upside down, then these 7 colors would combine to give us once again a white light, which tells us that the white light is made up of these 7 colors. We can split white light into constituent colors, and we can combine constituent colors to again bring about white light. Now what happens is, and why does this dispersion occur? The dispersion occurs because in general light travels with a particular speed in air, and this speed on all 7 colors is more or less the same. However, in different mediums, the speed of different colors is different. Now, whenever the speeds are different, then if we do this experiment in a well-lit room, you will find that the ray of light will take this particular path. Now, if we extend this forward and extend this ray backward, we will get an angle here. This angle is represented by small delta, which is written more or less like third of Hindi or Gujarati, and this is known as angle of deviation. The angle of deviation is dependent upon the velocity of light in the given medium. Because different colors will have different angles of deviation, they will bend differently. And therefore, on the screen, we get all 7 colors. The angle of deviation of red color is the least, and the angle of deviation of violet color is the most. Because violet color deviates the most, it is always at the bottom, and because red color deviates the least, it is always on the top. Even in a primary rainbow, if you very deeply observe, you will find that the red color is always on the top. Rainbow, however, is a different phenomenon to which we will be coming later. So this is dispersion of light because of the difference in angles of deviation, which is because of varying velocities of different colors in different mediums. Now, we already know that white light is made up of 7 different colors. Then do all 7 colors really exist? The answer is no. There are only 3 colors that actually exist. The 3 colors are red, green, and blue. These are the only 3 colors that really exist. Now, how do we get a pure red color? We cannot get it by making a chemical which is of red color. We will see how it is not possible to make some chemical with pure red color. However, in light, it is possible to get a pure red light. Same way, only in light it is possible to get a pure green light and to get a pure blue light. No chemical will have any of these as pure colors. You can see why at a later stage. However, if you take these 3 torches, one pure red colored torch, one pure green colored torch, and one pure blue colored torch, and if we focus the 3 circles on a whiteboard like this, we will find that the 3 colors where they superimpose each other, this part will always be white in color. So the combination of only these 3 pure colors can give us a white color. Here, however, we will be getting cyan color. Here we will get magenta, and here we will get yellow color. So all colors other than red, green and blue can be made by combining 2 or 3 of these colors in different proportions. Therefore, only these 3 colors are called primary colors. So primary colors are red, blue and green. All other colors, cyan, magenta, yellow, white, they are called composite colors. However, if you observe closely, then cyan plus blue. Cyan is a combination of red and green plus blue will give us white. Same way, yellow and red will give us white, and magenta and green will give us white. So we can bring about white color by combining only 2 colors as well. The 2 colors, out of which one will be a primary color and the other one will be a composite color. If we have a combination of 2 colors which gives us white color as a result, they are called supplementary colors. So we have 3 types of colors. One is primary color, the second is composite color, and the third supplementary colors. Primary colors, you cannot make them, they pre-exist, that is red, blue and green. Composite colors, we can make by different combinations of two or more colors, and supplementary colors are a pair of colors which gives the result as light. So these are the three types of colors that we have. Now exactly what happens when a ray of light strikes a surface. Suppose we have a surface and a ray of light strikes it. Some part of the light will be absorbed here, and the remaining light will be reflected back. Suppose the white light is incident on this surface. Out of the 7 colors of the white light, if this surface absorbs 6 of them, then the remaining light will be of the 7th color. And we can see this object as the 7th colored object. Suppose only red light is reflected and all these 7 colors, violet, indigo, blue, green, yellow and orange, are absorbed, then the object will appear to be red color. When white light is made incident on it. However, instead of white, let us say we incident a red light, then the entire red light will be reflected back, there will be no absorption. But instead of red, if we make incident a pure green light, remember I am talking about a pure green light, then the object will not appear red because the green light will be absorbed here, the object will appear black. Because entire green light will be absorbed by the surface of the object, and therefore there will be hardly any reflection of light and the object will appear to be black. So whenever all 7 colors of white light are absorbed by a surface, the object will appear to have black color. Otherwise, whatever be the color of the object, say the object is green, then out of the 7 colors, only green will be reflected back, and if we throw yellow light or blue light or red light onto it, it will appear to be black because it reflects only one color, and that is green. So this is how we see objects and their colors. The colors of objects are because of yet another phenomena of light, which is now known as absorption of light. This makes different colors appear to have different colors. However, we cannot make a chemical of a pure color. Why so? We all know that if it is a chemical or a dye, it will be made up of particles. If it is made up of particles, the particles are not going to get fused into each other. They will lie next to each other. In Therefore, getting one pure color is not possible in chemicals or dyes. So whenever we make, say for example, a red dye, it will not be exactly red, it will be magenta and not red. If we try to make a green dye, it will not remain green, it will be cyan. And therefore, all these, it will appear to a normal eye as red, but it will not be red, it will be magenta. So whenever we make a dye, the dye will be reflecting one or two neighboring colors. And therefore, a pure colored dye is not possible. Now we come to the third phenomena of light, and that is scattering. It is our common experience that all danger signals are of red color. It is also our experience that sky appears to be blue in color, but whenever we learn about the universe, we know that there is no light in the space, and therefore, because there is no light, it should be black, but it appears to be blue in color. Now what happens is that whenever a white beam of light passes through the atmosphere, now this all of you must have seen that in a small hut type of a room, there is a small hole in the roof. And if we have a hole, and if the light comes in, we will be able to see the light traveling right to the floor, and we will be able to see a circular dot on the floor. We will be able to see the path of light. Why so? We are able to see the path of light because of dust particles present in the room. These dust particles get lit up, and therefore we see the ray of light or the path of light falling right down to the floor. If all these dust particles will be removed, we will not be able to see the path of light, we will simply be able to see the circle that it forms on the floor. Because we have already learned in the last chapter that light itself is not visible. Say for example, there is a lot of light between me and the camera, but that light is not visible. However, when we are in an enclosed room which has dust particles in the air, and remember, these dust particles neither harm us and they stay in the air wherever you go. 100% pure air is difficult to get. We have too many gases and too many solid particles in the air around us. Now they do not harm us because our nose is designed in such a way that all these particles are filtered out and only pure air would enter the trachea. So they do not harm us. It does not make the air impure or unfit to breathe. They are naturally there, and it is because of these particles that something called scattering of light occurs. What would happen if we are in a dark room and we switch the light on? suddenly the room gets filled with light. We finish our work within the room, switch off the light, and what happens? Suddenly